All right, I guess we're on. Welcome, everybody, and thank you for joining the session on how to survive hybrid cloud on OpenStack and AWS. My name is Vivien. I'm head of IT for the Central Technology Initiative at ProSiebenSat.1 Media SA. A little bit about the company and the department to start with. ProSiebenSat.1 is one of the largest media group within Europe, owning several TV channels and also expanding into the digital area and e-commerce platforms and through acquisition of either startups or in-house developed solutions in this regards. What we will talk about during the session, first of all, why hybrid? What's the current picture of the platform we have and why did we design it this way? How did we get there? Which challenge did we face? What would be considered an achievement for us running application on this platform? What are the different drawbacks or pitfalls we've experienced along the way? And what would be the plans for the future? What's next for the platform? Before we get into the thick of it, a little bit about myself. I've been running infrastructure in general, our operation of IT platform for around about 10 years. Started in the game publishing business, and I started with projects like these ones, right? So for some of you guys that might be familiar with data centers, I guess the picture on the left is quite scary. Not quite full of the picture in the middle, but that's what happens when you're sleep deprived during a migration. And the picture on the right is the results of it, right? So yeah, I've been working with IT servers, virtualization for quite a while now. Was running jails on FreeBSD before containers became cool. And yeah, that's basically the background for me. So when it comes to hybrid cloud, I guess the first question we need to answer is, what's hybrid cloud? From my perspective, or from the experience I've had talking to different people on this specific topic, hybrid cloud is a bit the same as DevOps would be, in that sense that when you talk about people about DevOps and ask them what DevOps is, you're going to get a different answer depending on who you're talking to, right? Some people might mention the 3 ways of DevOps by Gene Kim, but across the board, each people are going to have their own answer of what DevOps is, which is fair because they need an answer that fits their needs and their business, right? When it comes to hybrid, it's pretty much the same. So for this session, I'm going to try to explain what is hybrid cloud for us and what we try to address with this setup, right? So obviously, we have one private footprint running OpenStack. And to go along with this, we needed one public cloud partner, which in this case is AWS, and we'll get a bit more in details as per why AWS later on. One of the first requirements we've assessed, again, tailored to the needs we have for the hybrid platform, is the direct connect solution that AWS is providing since, I would say, around about 3 to 4 years now. And basically, Direct Connect is what really is the central solution in this platform that allows us to consider it as one single platform, right? So we implemented the private part of the cloud in Frankfurt back in 2014, I believe. Back then, AWS were just announcing and releasing their cloud in their new region in Central Europe, being in Frankfurt as well. And the Direct Connect being available there as well allowed us to have very, very low latency between our data center and the AWS footprint, which is, again, one of the key factors that allows us to basically run hybrid cloud the way we understand it, which is basically being able to deploy hybrid applications on our platform, meaning that we are not going to run one application on the private cloud, one application on the public cloud, but really each application that we manage on this platform is running on both sides at the same time, active, right? So why hybrid cloud in general? Well, we try to leverage the best of both worlds, right? One aspect that hybrid cloud brings to us is resiliency, right? So most people that are running only one data center always have the concern of having a general data center global failure, right? Now with the hybrid cloud setup that we have, it's something that we can live through without any major issue, right? I mean, having your data center fail is always a big problem, and you're gonna have your sysadmins having a tough time, but what's important is that the applications that are running on the platform will remain online and reachable. Scalability is another factor. While it's quite possible to plan ahead the resources that you may need in the coming weeks or months on your private footprint, it's always nice to have the basically on-demand, virtually limitless capacity of a public cloud partner. Control, as in being able to deploy your application exactly the way you want, where you want. Transparency comes along with both the private cloud and the public cloud, as in being able to provide whomever is using your platform with an easy way to see exactly what they are using, for how long they've been using it, and what it costs them, basically, which brings the next point, cost efficiency. Right, running your own data center is definitely cheaper than using public cloud services such as AWS. I mean, I'm not quite familiar or up to date with the pricing on other solutions such as Google Cloud or Azure, but I strongly believe it must be the same. Obviously, the bigger your private footprint is, the cheaper it gets, right? For a single workload, that is. Another important aspect for us was no vendor lock-in, right? So, I mean, there's definitely a big push or big adoption rates for public cloud platforms, being, again, Azure, Google Cloud, AWS being the three main ones. But it's always a concern in Germany, mainly. There's no certainty that at some point in time, either AWS or Google Cloud, or again, all these major public platforms will remain in line with what the data protection regulation within your country is going to enforce on your business, right? Now, due to this, we need to be sure that we are able to offboard from any of these platforms in a timely manner, right? Now, if you're running your application fully on AWS, it might become a really, really tricky project if such a use case appears for you to actually offload this application and have it up and running somewhere else, especially if you go full force AWS using all their services, which are really useful and really fancy, but really locks you into the platform, right? The next one being the programmable infrastructure. The main point for this, and again, this is something you get both from OpenStack and AWS, is that we wanted to still give the flexibility to our development teams or operation teams in general to provision their own environment, basically to have full ownership of the applications, right? So, I mean, if I take an example of a developer behavior you could have on a more traditional hosting scenario where they would have to go through a ticket to request virtual machines to whomever's in charge to provision that virtual machine for them, have to wait a certain amount of time to get this machine and then have it configured through the next ticket. Usually you're going to end up with developer tells you stuff like, oh, but it worked on my machine, right? And this creates quite a lot of delays in your development lifecycle, and this is definitely something we didn't want. Right, so to get in the thick of it, the current state of our environment looks pretty much like this, right? So on the left side, you'll have the private cloud footprint running OpenStack. On the right side, you have the AWS either VPCs or account. We'll get a bit deeper into this later on. And in the middle, you have the direct connect. Right, so the way it works, we try to set up to focus on the OpenStack part for now. This is only one data center, right? So it's one data center on the left and basically one data center, AWS one on the right, even though it's several ones because of the availability zones. We try to replicate more or less the availability zone concept of AWS onto OpenStack. Now, OpenStack support availability zones per se. However, given the fact that our OpenStack environment runs into one data center only, we didn't want to use the availability zone support for this. We used the concept of host aggregates, right? So we separated the complete amount of compute and Cinder resources we have into 3 host aggregates so that we can ensure that if for some reason an application is deployed only on the OpenStack part and not on the AWS side, they still have a reasonable amount of high availability in terms of if one compute node goes down or one Cinder node goes down, for instance, well, they shouldn't have both their front end or both their back end basically deployed on that single host, because each one of these hosts will be in a different host aggregate. When it comes to the direct connect itself, in this specific setup, so again, having our data center in Frankfurt and the AWS region being in Frankfurt as well, the kind of latency this direct connect setup provides to us from an instance running on OpenStack to an instance running on AWS is 1.5 milliseconds. Now, this basically allows us for one of our main applications to run our MongoDB cluster on both sides. So it's a sharded cluster, and you'll have half of the environment, or actually 2/3 of the environment running OpenStack, 1/3 running on AWS. Right. The setup for the direct connect itself is pretty straightforward and pretty easy, right? So all you have to do basically on your AWS side is once the direct connect is connected, you'll have a virtual interface linked to your account, and then you'll have to set up a virtual private gateway for each of your VPCs, and then push the routes that you want to push to map the subnets that you'll be using on your OpenStack tenant to the subnet VPC or account on the AWS sites. Now, on these specific pictures, we have listed several VPCs, which would be basically the AVS sides of the tenants on the OpenStack side. It can also be accounts, right? So your direct connect setup is not bound to an account. You can have one direct connect linking to several accounts. Right, once you have your routes, virtual gateways, and virtual interface set up, all this will be pushed through BGP to your OpenStack environment, and at this point, normally your workload should be able to communicate with one another. From the application perspective, it looks more or less like this, right? So our main entry point in our use case is by default always the uplink that we have in our data center, right? So the public traffic is routed through our entry point there, so through our routers, our load balancers, and then distributed to the actual workload on the applications. Now, the good thing that we can do, again, leveraging the fact that we have the direct connect through our load balancer, is that we can load balance the traffic coming to our data center through our load balancer to both our OpenStack instances and our EC2 instances, right? Which allow us to basically use the concept that our main workload, obviously to use up as much as we can the actual hardware that we've purchased and that we're using in the data center, resides on the OpenStack side, and that would be basically tailored to the minimum capacity that is needed for the application to support the traffic, right? Now, for everything else, which could be spike of usage or event, then we use the auto-scaling concept of AWS. If we do not have enough resources on the OpenStack part, otherwise you can do the auto-scaling there as well. Nevertheless, the idea and the concept we have for our application is to always have a minimum viable setup on AWS as well to prevent the application going down or being disrupted in case of a global failure of the data center part, right? Now, this is all nice and shiny when the entry point is on the OpenStack part. When, for some reason, for instance, if we had a failure not necessarily on the global data center part, but on the edge routers, either of the ISPs or the data centers, or if some, for instance, DDoS attack would be basically throttling our bandwidth on the uplink, we can, through Route 53, route the traffic to the ELB instead that is already pre-configured on the AWS side, which means that the traffic, instead of going this way, would be entering this way and be balanced there, right? Which is one of the main reasons why we have a minimum viable footprint on AWS. Now, the problem we have with this is that depending on what application you're running on your platform, you may or may not need SSL offloading on your load balancers, right? Now, if you don't need it, Then AWS released, I guess, early this year or mid this year, a new type of load balancer called NLB, Network Load Balancer, which finally allows you to balance your traffic to non-AWS resources, which was, in our case, one of the biggest limitations we had with this concept is that with ELBs and ALBs, well, you can only basically add AVS instances to your load balancer pools, right? Which means that if this link here is down, all this payload here, our workload, is basically still viable and working properly, except it's not being routed any traffic because the ELB there can only route the traffic here. Now with the NLBs, you can finally route the traffic to both your AWS and your OpenStack payloads, which is great, but it does not support SSL offloading. So it might solve the issue of some internal load balancer that you would have behind your front ends, but if you do need TLS or SSL termination on your load balancer, then it's something that, as of today, is still not possible. Knowing AWS, it may be coming. Nothing was confirmed on this side, however. Now, just another nice functionality that you get from Route 53 actually is the possibility to actually do a health check on the endpoints. So you don't have to do an either or on where the traffic is being routed for your entry point, but you could just add both and advertise both entry points so that basically half of your traffic goes through your load balancer on the data center and half of the traffic goes through the ELB or ALB or NLB that you have as public facing on your AWS footprint. Right. So how did we get there? It was a rocky ride. It took us pretty much, I would say, around about a year to actually get to this picture. One of, I would say, the most important guideline that we had to really stick to was what component can we use, both on the OpenStack and the AWS side. Now, as I mentioned earlier, AWS, I'm guessing most of you guys are familiar with it, has a lot of really, really cool features that are really nice to use, really easy to use and to implement. However, they cannot really easily be replicated on the OpenStack part. If I take for example, one of the most common one being RDS, we don't have anything that could replicate what RDS does on our OpenStack deployment, right? Small parenthesis there. The OpenStack deployment we are using is actually quite old, so we're running on Kilo, right? And we're basically only using Nova, Cinder, and Neutron, right? We try to keep it as simple as possible, the team managing the environment being quite small, right? So it started basically 2 years ago with me alone. And as of today, we have 3 people managing the complete cloud, being the private or the public, and also the applications running on top of that cloud. Some of them being developed by our own department, some of them belonging to other units. Right, so for these reasons, we basically wanted to have a concept where we do not want to tailor the way the application is deployed to which side of the cloud it's going to be running on, right? So we didn't want, for instance, to leverage RDS on AWS, which is very powerful and very nice, but then have to do a specific configuration for the same application when it's running on the OpenStack side, because, well, RDS is not there, so we'll have to, add our own instances running MySQL or MariaDB and have a specific way of deploying it. So because of this, we just ruled out any kind of AWS services that was not replicable easily on OpenStack. There is 2 exceptions to this, though. One of them is CloudFront. Obviously, we use CloudFront heavily, and we don't necessarily see CloudFront the same way we would see other services, in that sense that we can use CloudFront independently of the workload running on AWS. And the other one, the other services being the exception is Route 53. Right. Now, the next major key point that allowed us to get there is config management, everything, right? So as I said, we want to have the same setup depending, regardless of whether the application is on the OpenStack side or on the AWS side. Quick question, when it comes to config management, how many of you guys are using Ansible? Right, Chef? Puppet? Salt? Yay, 2. So we are using Salt. Different reasons. We're actually quite fond of the agent-based setup that Salt provides. And Salt also came along back when we had to decide which config management to use for with Salt Cloud, which allows us to basically go full fast config management on provisioning the machine without having to first pop the machine and then have the agent hook into our Salt master and get the config, right? So based on Salt Cloud, we can just talk directly to the OpenStack provider or to the AWS provider, and Salt Cloud is basically handling the rest. The concept we have when it comes to config management with Salt is that basically the only hard requirement we have is we have a very strict naming policy when it comes to the FQDNs of the machine we're deploying, right? So every single VMs we have is going to be named following the pattern that first part is going to be whatever application the VM is deployed for. Second part is going to be which environment of this application. Is it a staging environment? Is it a QA environment? Is it a production environment? Then you're going to have the role of the VM. Is it going to be a backend? Is it going to be a database? Is it going to be a front end? And then you have the top domain name, right? Now, based on this, Salt will know whether it should be running on OpenStack side, on the AWS side, and we'll know all the recipes that it has to deploy on the host. So what users, what applications to deploy on it, and which configuration to attach to it. And this is basically really what allowed us to manage and to still manage and operate this platform with such a small team, right? To put things into perspective, we are currently hosting on this platform, I would say around about 15 e-commerce platform. Altogether, it's around 450 VMs. I would say 300 of them running on the OpenStack side and 150 of them running on AWS. Right. Coffee and painkillers, well, pretty standard, I would say, for anybody managing something like this. It was not an easy ride. We're quite happy where we are today, but there's still quite a few choke points that we'll be mentioning later. Now, one point I didn't mention, and that is, I believe, quite important to state when it comes to why the hybrid setup in general. When it comes to the budget and again to the pricing, this specific project was started as a strategic project, right? So we wanted to basically have a way to provide development teams and operation teams with a platform running on-site, fully belonging to our company, seamlessly same capabilities as you can get with public clouds today, right? So when you onboard new developers or new teams, most of them as of today are going to be used to work with API-driven infrastructure, and they're going to want to be able to pop their own VM and stuff like this. And we wanted to have a platform that can actually allow them to do this. One of the other factors is that depending on which company you're working with and which type of budget you may have, you may very well have CapEx budget, but not OpEx budget, or vice versa, right? Now, this specific platform, leveraging both an on-premises data center and a public cloud, allows you to basically shift which kind of budget you want to spend, right? If for some reason you have only CapEx budget, then you can scale your private footprint. If you have only OpEx budget, then you can scale and shift your payload usage a bit more towards the public cloud rather than private cloud only. Right, so next up. Well, basically the achievement we'd had with this platform, the first business unit to fully migrate from their previous hosting partner to our solution there. And here I gotta say that they are actually using only the OpenStack part of the cloud, not the AWS part at this point in time, though I believe this is about to change. They basically, after 2 months, assessed that they were saving 60% on hosting cost alone, just by being able to tailor their workload to what they actually needed, just by being able to define the size of instances that they want rather than use predefined sizes that, for instance, AWS locks you onto. So for instance, if you want a compute optimized instance on AWS, you can basically look for a C4 large, a C4X large, which is basically double of the C4 large, et cetera, et cetera. But if you want something in between, well, you can't really achieve this, right? On OpenStack, you can. And leveraging this, they were able to really tailor the resourcing they were using to actually what they needed and save the cost that they mentioned here. Another achievement that we are quite proud of, actually, even though it was painful to get there again, is due to the fact that we are, for the applications that we are running and managing ourselves on this platform, we are able to basically withstand a full restart of the OpenStack environment, right? So we'll come later on as per why we actually had to do this, but we were able to basically restart in turns, not all at once, but in turns every single hypervisors in the private cloud, and the applications remain online, undisrupted, and fully reachable, right? Right, so there was quite a few problems getting there. There's no real order of which one is the most important one. It's just exhaustive list. It's really, really hard to keep with new functionality, tools, best practices when it comes to both OpenStack and AWS, right? Again, I don't know, how many people here are using AWS? Right. Right, so I don't know if you get all these news either through the website or AWS, or if you're on enterprise support or business support and you get actually the mail from AWS directly. But yeah, basically I'm getting new emails every week. It's impossible to keep up with all the new features that AWS is releasing. When it comes to OpenStack, it's not as fast-paced, but it's still really fast-paced, at least for us. Again, team of 3 people, managing this environment, it's really hard to keep up with what's out there, what new feature could actually address issues that we are facing, but without really having the time to dig into each of these new features, you can't really see that they're actually addressing issues that you're spending time troubleshooting at the moment, right? Right, OpenStack is great as long as everything is fine. OpenStack itself, from my experience, is quite reliable. I guess even more so now that some people are running newer version than we are. Hopefully the upgrade will come soon. The issue I see with that, however, is that OpenStack does rely a lot on a broad scope of technologies, right? So if you take compute, for instance, depending on which hypervisor you're running onto your physical machines, in our case it's KVM, you're going to be relying on libvirt, you're going to be relying on QEMU, you're going to relying on really a large set of technologies. And whenever you have an issue, well, you don't know where to start debugging, right? So you have to go through the whole chain, try to assess what the actual root cause is, and this can be a really, really lengthy and painful process. Even more so because actually getting people that have the skill set that covers the broad area of OpenStack is quite tricky, right? So if you want somebody that can basically manage or tackle any kind of issues, you're going to have an OpenStack. You're going to have to find somebody that is quite deep into Unix, Linux itself, into the kernel, into virtualization, but you're going to need somebody that is also quite proficient into networking, right? Networking is a big issue, a big topic, and we had quite a few issues with it. I would say one of the main issues we had came together with MTU and packet sizes. This is also due to, I would say, a lack of preparation on the architectural concept when we actually set up the cloud initially. So MTU is not necessarily something you think about from the get-go, right? But the problem is that once your cloud is deployed in an environment, it's actually quite tricky to go into this and modify it everywhere, right? So you can modify it into your hypervisor or into your neutron config, but you also need to deploy these changes onto your routers, your switches, and whichever network components you may have on the underlying network, right? Right. Right, and this is only for the network part, right? You also have, as I said, we use Nova, we use Neutron, we use Cinder. So when it comes to Cinder, you're going to have somebody who's quite proficient into storage, for instance. It can depend on which storage you're using. In our case, we're using either local SSDs or Synology backend NAS, which is nothing rocket science, but it still involves iSCSI to a NAS, which in itself also involves networking. And whenever you have an issue in this, it can be, again, really painful to troubleshoot. One of the issues we've experienced, actually a few weeks back, is something that is really mind-blowing from our perspective, because the cloud has been running for 1.5 years with production payloads on it, and it was running perfectly fine without any major issue for, well, up until a few weeks ago, right? The issue we faced is that randomly we had some VMs that basically had their connection, their iSCSI connection to their volume hang, right? So with the first few VM where it happens with the connection to an iSCSI volumes that was residing on the NAS, right? So, I mean, you go through the logs, you try to troubleshoot and find out the root cause of this, and one of the assumptions you may have is that it could have been an issue with the NAS itself, or with the storage network between your compute nodes and the NAS, right? But then the next VM that encounters the issue has the issue with an SSD volume that is actually on the same hypervisor. So you try to rule out the network issue because obviously it doesn't seem to be a network issue, and you basically back at square zero, right? Now it's quite an interesting issue, and I actually discussed this a few minutes ago with the Cinder team right after the presentation, and they were pretty much at a loss as well to explain that kind of issue. So as of today, we didn't basically find the root cause for this issue, right? Our hope is that the upgrade that we're actually planning to do and started doing already of the complete environment will solve it, and that basically will be good to go again. But this is basically what I mean with OpenStack is great as long as everything is fine, right? Because whenever you have an issue, it could basically be anything. And whereas it may be sufficient to have a team of 3-4 people, like the Adobe people presented during the keynote, for instance, to actually run and manage an environment like this, as soon as you have an issue, well, you're going to find yourself with a shortage of resources for troubleshooting issues like this quite fast. Or at least this is our experience of it. Right, so what's next for us? Terraform. The need we have for Terraform, or at least the use case we see in there, is what I mentioned earlier, that we are really trying to use configuration management for everything. So we rarely go, or we actually never go into any machine via SSH to try and update a package and stuff like this. There is still quite a bit of manual work to prepare environments for new applications or for new environments for specific applications. So let's say we want to add, I don't know, a new pre-prod environment for specific applications, right? This means basically a new tenant on the OpenStack side, a new VPC on AWS side, or a new account, which in turn means having a new virtual interface populated, a new virtual gateway, new routes pushed, and this is all something that we still do manually as of today, and obviously it's far from being idle. Now, SaltStack to some extent can tackle some of these topics through SaltCloud. However, we have the feeling that Terraform is way better suited for this kind of automation and provisioning than Salt is. So we really want to make a distinction between Salt being the config management for the payload running onto the VMs, and Terraform being the automation that we are actually using for populating the infrastructure below it, so VPCs, network, subnets, security groups, etc. Another public cloud partner, this is not quite clear yet, but it's definitely the way we want to go. Possibilities being, again, Google Cloud, Azure, or maybe even an OpenStack-based public cloud partner. Really depends on what the future will bring in terms of functionalities in these different partners. As I mentioned already earlier today, we are currently kickstarting an upgrade of the environment together with Mirantis. They've got a booth on the marketplace, if you guys are not familiar with them. MCP actually brings a lot forward, right? So the upgrade has two focus points for us. One of them is actually getting up to date because running Kilo is not so comfortable anymore. I guess you can imagine. And the other thing is that Mirantis in MCP bundles basically a lifecycle management for your OpenStack deployments, which in turn will allow us to go through the update of OpenStack itself, the OpenStack version, and all the components that come with it without having to basically go through such an effort for the upgrade, right? So this upgrade is going to be quite painful, especially because we're migrating to OpenContrail as well, and I will address this as per why later on. But hopefully it will make the next upgrade a lot easier to manage. OpenContrail, one of the main reasons, because actually we were quite happy with Neutron and Open vSwitch. It's quite simple to manage and it works. But we did run into an issue that we actually didn't plan again in the initial scope of the project, right? And this issue is how to manage the available subnets and the subnets in general between OpenStack and AWS, right? So as I said earlier, when you link an AWS account or an AWS account or an AWS VPC to the OpenStack environment through Direct Connect, well, you're going to have an issue if two different accounts or two different VPCs are using the same IP space, right? Because through BGP, it's basically going to route your traffic to the first occurrence that matched the route. And if you have two of them using the same IP space, well, one of them is not going to get any traffic, right? So as long as you manage all the applications running on there and that you have your hands on all the accounts, it's fine because at least for a while, you'll be able to use different networks. I mean, at some point, you're going to run out unless you use really small networks, but it's fine. But we also have some of the business units using our platform as a, I would say basically platform as a service. So we basically provided them with the API endpoints for OpenStack, and we set up the direct connect to their AWS account. But after this, they are basically free to do whatever they want, right? And in that case, it means that they are free to use whatever subnet they want on the AWS side. And as of today, with Neutron and Open vSwitch, we couldn't come up with a viable solution on how to prevent the BGP and routing issue we'd be facing in case of them using a subnet that we are already using on AWS. So this is one of the major drivers behind the adoption of OpenContrail, because we believe that OpenContrail will give us the flexibility to actually tackle this issue. Right, and I would say the last point we'll try to address with the upgrade, actually this is part of the upgrade, it's to actually introduce a CAS solution and bare metal deployment to the cloud itself, right? So the idea being that we really want to have a platform that can basically answer or provide any kind of workload that one of our customers or partner could be asking us for. As of today, if they ask us for bare metal servers, we can't really provide this. For container environment, we do have a Rancher deployment running on virtual machines, running on OpenStack, but this is far from being ideal for a real, basically, solution as a service for the customer, because they still have to go through us to leverage what this deployment can do for them. Right. So that's pretty much it. Do you have any questions? Yes. I guess there's a microphone coming for you if you want to wait a second.
Hi. How do you solve the flavor and image management problem between AWS and OpenStack?
What do you mean?
How do you map OpenStack flavors to AWS flavors, or the images that you use to spin up VMs on OpenStack to those in AWS?
Well, we don't map them together. This is handled via SileCloud providers. Basically, in SileCloud, you can define which is going to be your provider based on the host name again, right? If the provider is OpenStack, then we just need to specify when we spin up the machine which flavor we want to use. And if it's AWS, then you just need to specify which instance type you want to use. But there's no mapping between them.
OK.
Here. Sorry.
You mentioned before that there was certain guidelines in terms of what services can be used in AWS and OpenStack. Have you had much kind of pushback from the developers or from the rest of the business in terms of we want to use this particular service or we want to use AWS specific services rather than the private?
So from developers from our department, I wouldn't call it pushback. I mean, it was mentioned, it came up several times, yes. However, we work very closely together and they're also involved to a certain extent into this project. So they're actually quite aware of the limitations we have and, you know, they know that it may not be so comfortable for them, but these limitations are here for a reason, right? If we want to keep control of the environment, we actually do have to restrict ourselves to these guidelines. It may not be the case, and we may be able to, you know, use more of the services in the future after the upgrade, for instance, or by implementing more services from the OpenStack community into our private cloud. But as of today, it's not the case. When it comes to developers from other teams, so basically business units using our platform but not having their stack managed by us, well, they did mention it. In that case, they're pretty much free to do whatever they want, right? So basically, we'll tell them, well, if you want to use this, you can. However, be aware that if you do this, well, you're not really deploying your application in a hybrid model anymore, right? So that's pretty much it.
I just have two questions. So first, you back to your sliders, just to show the direct line.
Sorry, what?
Direct line.
Direct connect, yes.
Yeah, direct line between the AWS and the private cloud.
Yes.
So my question is, you mean the direct line is you to buy the service from the operator or you build by yourself?
Yes.
Yes, you build by yourself?
The direct connect? Or
Yeah, direct line. You back to the last page.
Direct connect is an offering from AWS, right?
Or from AWS?
Yeah. So it's a service from AWS that basically provides you with a private link between AWS and your data center. So it's not available anywhere, right? So you have to be basically in a data center that is a partner of AWS or that is a partner of AWS. So for instance, in Frankfurt, the direct connect terminates in Equinix data centers, right? We are not with Equinix. However, the data center we are using works with Equinix, right? So basically, AWS provides a termination for the direct connect at Equinix, and our data center provides the link between our footprint in their DC to Equinix.
Okay. The second question is, you mean the load balance?
Yes.
Right. So the load balance solution is you provide or you work to cooperate with other vendors. As your solution, the load balance.
For the private part, for the private cloud.
Yeah, private cloud. Yeah.
For the private cloud, the load balancer we're using is actually an A10 load balancer.
Okay.
So it's integrated with OpenStack, meaning that we can create the pools, add, remove members from the pool through Neutron, but the load balancer itself is a physical load balancer.
Yeah, so just one question. What the developers on your team, what difficulties do you think were the greatest difficulties in writing applications that were agnostic to both clouds? Like something that would run in AWS and OpenStack?
That's a good question. Right, so there's only one example that really comes to mind in terms of them seeing a limitation on either side, and it would be when they try to implement mesh services for one of the applications. So most of the applications we are hosting are Node.js-based applications with MongoDB backends, right? And for one of the applications, they try to implement a mesh services. However, due to the amount of nodes and services that were registering to each other through the mesh, it was actually creating quite a lot of issues on the OpenStack side. May or may not have been related to MTUs or actually the way OpenStack and Neutron on our environment is handling UDP package. That's something we didn't quite identify yet, but due to this, they actually reverted from using the mesh architecture for now. Also because they also find another solution that worked better, but this is definitely I would say, one of the examples where we assessed there was a limitation on the OpenStack part, because on AWS side, where the mesh was also deployed, we didn't experience any issues at all. So again, there we come back to the fact that when you run an OpenStack environment yourself, you really run into issues that could be caused by any part of your stack, and actually troubleshooting this issue can take a really, really long time, right?
Thank you.
Just out of curiosity, are
Yeah.
you using Route 53 as your primary DNS?
Yes.
Is that how you affect your failover from your data center over to AWS if you have problems with the ISP at your data center? Is that the mechanism?
Complete DNS announcement is handled via Route 53. Something we are testing as of today, and not completely in place, is the automation of the failover. Basically, you have health check on Route 53 itself, check for whether or not your two different endpoints are reachable and healthy, and if not, just remove them from the announcement.
Currently, it's a manual process that you have to switch the route manually.
Currently, it's still the case, yes, on production environment. But I mean, realistically speaking, it doesn't happen quite often that either side is, not reachable. I mean, I think it happened once, and that was because of a maintenance side on our data center part and a misconfigured failover scenario on the edge routers. So in this case, yes, we had a 5-minute or a bit more than 5 minutes downtime on the private part, but the application was still fine because we recognized it straight away and switched to the public part, right? But the automatic part is already in place on our testing environment, and we just want to make sure that it's not going to create any unnecessary failover.
Yeah,
exactly.
That's a huge problem.
Exactly. Right. Yes?
So earlier, you talked about the OpEx and CapEx
Yes.
dynamic, right? As well as the way you interface with the system, where there is AWS part of it and the OpenStack part of it. So I'm just wondering how it gets used in a day-to-day environment, where if I'm a developer, I want to spin up a VM, how do I decide whether it goes to AWS or OpenStack? And do I use a different API altogether? So do I use EC2 API when talking to AWS?
No, so the developers of our department basically do not talk directly to the API of the provider. This is all handled by SALT, right? So SALT Cloud is the one that has whether or not it's going to be in AWS or on OpenStack instances. When it comes to how it impacts the developers, basically our guideline internally is as long as we have resources on the private cloud, go for it. When it's for test and QA and stuff like this, right? When it's for production, it's a different story because we want to ensure, as I mentioned, that we have the minimal viable deployment present on AWS to make sure that the application will be able to withstand any kind of traffic. May the private part go away for XYZ reason, right? But for everything else, default policies, we have resource available on OpenStack, go for OpenStack. Okay, I think I'm out of time now. So again, thank you very much for listening and for joining.